Hey guys, so this video is for my Chem 101, my intro chemistry students, and this is lab 3, the mass conversions to moles and atoms, and this is exercise 1, the one where you do the aluminum cup, glass stir rod, and cotton ball. So what the first part of this lab is intending to tell you is that a mass conversion, okay, so you have a scale and you can easily put something on the scale and you'll get a gram reading, right? A kilogram reading, pounds. You can get these readings after you put something on the scale. But can you put something on the scale and get it to tell you moles or atoms? No. We have to do these conversions ourselves with the molar masses. So let's pretend that I went ahead and weighed out my aluminum cup, my glass stir rod, and my cotton ball, and I got these 3 masses. Your masses will be different, right? So the first thing they ask you to do is to, first, we're going to have to calculate the molar mass of aluminum, glass stir rod, and cotton ball. So aluminum, the molar mass is very easy. All you have to do is look at the periodic table for aluminum, and you'll see that aluminum weighs 26.982 grams per mole, right? So we'll do aluminum first. Let's do aluminum first. So I found the molar mass. That was one of their questions, right? And I found the mass of my sample. Now I need to find the moles of my sample. So to go from grams to moles, remember our molehill? To go from grams to moles, you use the molar mass. And I have the molar mass. So if I have molar mass and it's in grams per mole and I want to end up with mole, I put mole at the top. Another way to think about it is take your given 2.95 grams of aluminum, put that over 1, and then I'm going to need grams of aluminum on the bottom, 26.982 grams of aluminum for every 1 mole of aluminum. Oops, squeaking that on by, right? Okay. And then you multiply the top and divide by the bottom. So essentially, I'm going to take 2.95 and I'm going to divide it by 26.982. And I get 0.109 moles. Now, does this make sense to me? Why would this make sense? If I had a full, oh my goodness, I just realized that I was not showing that. Okay, there we go. Sorry, I was on another screen. So my 2.95 grams of aluminum over 1, and my 1 mole of aluminums, you put that over the grams of aluminum. Grams of aluminum cancel out, you're left with moles. So 0.109 moles, right? Why does this make sense? Because if I were to have a full mole of aluminum, how much aluminum would I have? I'd have 26 grams, right? About 27 grams. But I don't. I only have just under 3 grams. So it should be a small fraction, right? So that makes sense. And then the next question they have is, well, why don't you turn those moles into atoms? So remember, to go from moles to atoms, you use Avogadro's number, which is the 6.02 times 10 to the negative, or 10 to the 23rd. So start with your given, 0.109 moles of aluminum. And I know that for every 1 mole of aluminum, I have how many atoms of aluminum? 6.02 times 10, 22 times 10 to the 23rd. Atoms. Right? Now, moles are going to cancel out, and I'm left with just atoms. So remember this ratio. If you want a mole of atoms, you're going to have 6.02 times 10 to the 23rd atoms. So multiply by all the tops, divide by all the bottoms. The bottoms are all just 1, right? So I'm going to take 0.109 and I'm going to multiply it by 6.022, and then in this calculator I actually have a times 10 to the button, which is really handy. So I have a times 10 to the button, so 10 to the 23rd, and the parentheses, I just like parentheses, that's just me. 6.56 times 10 to the 22. Atoms of aluminum. Let me make sure that that's the only thing you have to do with atoms. Yep. Now let's do the glass stir rod, and then that should be enough to help guide you into how to do the cotton ball, right? So the glass stir rod, I weighed it, I pretended to weigh it, and I got 7.22 grams. So let me rewrite that right here. Glass stir rod, 7.22 grams. So I need to convert this to, according to their assignment, I'm going to convert this to molar. I need to find the molar mass of silicon dioxide. Remember the last time we found the molar mass of aluminum, and it just happened to be what? The molar mass of aluminum. But they tell me here glass is made of silicon dioxide. So that means one get focus in there. 1 silicon and 2 oxygens. So let's look up the molar mass of silicon. That is 28.086. And the molar mass of oxygen is 15.999, but I'm going to need 2 of those, aren't I? Right? So it's really 28.086 plus 31.998. Now what is this? That's 68.048. Oh, sorry, 084. And that's grams per mole. The unit from the periodic table is always grams per mole, right? So that was one of the questions that they asked us to do. Recall, we did silicon, we found the mass for him, the molar mass, and then we found the molar mass for oxygen, but we took 2 of them. So if I wanted to find the number of moles of the glass that I have, I would have to take this and do what? Use the molar mass. So put 7.22 grams of SiO2, put that over 1, and then with this number, 68.084 grams per mole, do I put grams on the bottom or the top? The bottom, so that they cancel out. And I've heard it said before, the desired unit is mole, right? I'm looking to get mole as my final answer. So 1 mole is the same thing as 68.084 grams of silicon dioxide. 1 mole of silicon dioxide. So why does this all make sense to me? Because I looked at, okay, so let's keep going. So am I expecting to get a big number or a small number? Well, if I wanted to have a mole of glass, I'd have just about 68 grams of glass. But how many grams of glass do I have? I have much less than 68 grams. So I'm going to get a number that's smaller than 1, correct? So 7.22 divided by 68.084. I get 0.106 moles of SiO2. Right? Now, they ask me for the moles of each element. Here's the tricky part. We have to know that if I have a mole of silicon dioxide, right, for every 1 mole, I'll even write this out. For every we'll even go molecule of silicon dioxide. How many molecules of Si do I have? I have one molecule, one atom essentially of silicon, right? And I will have 2 atoms of oxygen. Guys, see how that works with the formula? So if I have 1 atom of silicon, I must have 2 atoms of oxygen. That's the formula. That logic goes the same. So you will have 1 mole of SiO2. You will have 1 mole of Si, and you will have 2 moles of O. So let's pretend we have 1 molecule. Let's pretend we have 1 mole. So what I'm saying here is that if you have 1 mole, so I'll show you the math and it might work out, or it might make sense then. 0.106 moles of SiO2. I know that for every 1 mole of SiO2, I will have 1 mole of Si. Multiply the tops, divide by the bottoms. That means I have 0.106 moles of Si. Silicon atoms, right? And then 0.106 moles of SiO2. For every 1 mole of SiO2, I will have 2 moles of oxygen. So I really have 0.212 moles of oxygen. Does that make sense? I hope that makes sense. So then the very last thing that they do is they ask us to take those moles of each element and then turn them into atoms of each element. So I think that understanding this part was probably the hardest, to understand that for every 1 mole of silicon dioxide, you have 1 mole of silicon, and 2 moles of oxygen. So essentially you just had to multiply it by 2. So then the next part is just basically the same as we've done before. So to find atoms of silicon, we would say I have 0.106 moles of silicon, and I know that 1 mole of silicon is the same thing as 6.022 times 10 to the 23rd atoms of silicon. Multiply the tops, divide by the bottoms, so it's really just 0.106 times 6.02 times 10 to the 23rd. So I got 6.38 times 10 to the 22 atoms of silicon. How many atoms of oxygen? So I have 0.212 moles of oxygen. Put it over 1. And I know that for every 1 mole of oxygen, I'm going to have 6.022 times 10 to the 23rd atoms of oxygen. So multiply the tops, divide by the bottoms. So I'm just multiplying 0.212 times 6.022 times 10 to the 23rd. I get 1.28 times 10 to the 23rd atoms of oxygen. So that's how you do the second part of experiment 3. Or the second part to experiment, sorry, Lab 3, Experiment 1, the second part. The third part, you're going to be doing cotton ball, right? So the cotton ball, your hints, if you're still working on this one, sorry, focus. The cotton ball has a formula, a molecular formula of C6H10O5. So you're going to multiply 6 times whatever carbon molar mass plus 10 times whatever H is molar mass plus 5 times whatever oxygen's molar mass. The hint is it's above 100 grams per mole, right? And then you're going to find the total moles the same way we did it for the other two, and then the moles for each element. For every 1 mole of this, you're going to have, and this will be your hint for that part, for every 1 mole of this, you're going to have 6 moles of carbon, 10 moles of hydrogen, and 5 moles of oxygen. So whatever the moles is that you find for this, you're going to multiply it by 6 to find moles of carbon, you're going to multiply it by 10 to get moles of hydrogen, and you're going to multiply it by 5 to get moles of oxygen. So that's your hint for that part. And I do hope that this all helped. I will see about making another video for the rest of the calculations for this lab, but hope you enjoy. Have a good day.